So, today we are talking about domain and range. Go ahead and throw your name on here in case they fall out of your notebook. It is currently second hour. Okay. Domain and range are two vocab words that we use to describe all of our possible x values and all of our possible y values. So domain is all of our possible x values, and range is all of our possible y values. If you can remember, it goes in order domain and range, because like range and domain sounds weird, I feel like. So domain and range, x and y is alphabetical. So x comes first, then y, domain comes first, then range. Additionally, a way that I was taught that helps some people remember, domain, I think about dominoes. Dominoes fall from side to side, your x values go from side to side. And then range, if you think about a mountain range, mountains are tall, you climb a mountain, so you go from bottom to top when you climb a mountain. So, just ways to remember which is which. So like I said, domain's your x values, so that on your x-axis is going to be from left to right. You always have to start on the left. For range, you are going to start at the bottom and go to the top. So domain and range are one of those things that it's like so simple yet so complicated at the same time. When we are finding domain and range, we are just looking at a graph and we're listing the furthest to the left it goes to the furthest to the right. So for domain, we are going to list the leftmost x value, and then we are going to list the rightmost x value. For range, we do the same thing, but from bottom to top. We list the bottom y value, and then the top y value. There are going to be a lot of times where your graph just keeps going because there's an arrow at the end. So if your graph continues forever, it will have an arrow either at the furthest left, the furthest right, the lowest, or the highest. So if anywhere there's an arrow and it's continuing forever, we are going to write an infinity symbol instead of a number there. If that arrow is on the left or the bottom going down, we are going to use negative infinity. Because if we think about on our x-axis, if we were going to go farthest to the left, negative 10, negative 11, negative 12, keep going forever and ever, it would be negative infinity. If it's to the right or up, so in the positive directions, we are going to use a positive infinity. Alright, we are only doing domain and range for these problems, and so you'll do the domain and you'll do the range, but you're going to do them twice each, because we're going to write them in two different notations. So we're going to write them in inequality notation and interval notation. So notation just means like how we notate something, how we write something, and these are just two different ways that get used for different applications, and different people use different ones. I'd rather teach you both of them and challenge you with both of them now than only teach you one and then have you show up in a class in a couple years and for the one I taught you to happen to be the opposite of the one that you were expected to use. So we'd rather teach you both than only teach you one or the other because we don't know which you're going to use in the future. So inequality notation is going to have inequality symbols. We will use a less than symbol if a value is excluded or infinity. And the reason why we are using less than symbols for infinities is because you can't ever make it quite to infinity. Infinity is a concept. It's not a number you can hold in your hand. We will use less than or equal to symbols when a value is included. So for our purpose today, that's going to be almost every time we have a number, we'll use a less than or equal to symbol. Okay. Interval notation, we use either parentheses or brackets. And we say the left to the right, we put the two numbers together and we either put them in parentheses, so it kind of looks like an ordered pair, but it's not. Or you put them in brackets. We will use parentheses for those values that are excluded or infinity. And then we will use brackets for those values that are included. Alright, there is one last thing down here. This is kind of separate. We're going to come back to this because I've told you like a million things and I want to go use some of them on our examples. And then we'll come back to this is it a function thing. This is just one little extra thing. It's not hard. So, any questions right now? I don't know what questions you would have. Okay. So, like I said, domain and range is like very straightforward, but somehow very complicated at the same time. So just pay attention. If you have questions, ask them. And don't overthink it, okay? Listen to the words I'm saying. So domain for this first graph, we are looking at where this circle is on the graph. So we have the grid to show us where things are, and then we're looking at the shape. So this one we're looking at a circle, this one we're looking at this little V, this one we're looking at this little curly Q guy. So for this very first one, we want to look at our shape, and we want to look from left to right for domain. So I'm going to put a little line. The furthest left it goes is right there. So the furthest left my graph goes is -5. The furthest right my graph goes is +1. So I'm just seeing where it fits in from left to right. We are then going to write that in two different notations. The first notation is going to be our inequality notation. So we are going to say that our x's start at -5. So -5 is smaller or equal, so less than or equal to, all of our x's, and all of our x's are less than or equal to 1. So it's a little sandwich there, where all of our x's are in between -5 and 1. Okay, let's go ahead and look at our inequality notation for our range, and then we'll turn both of those into interval notation. So for our range, what is the lowest my graph goes? -1. Yeah, so right here, -1. I'm looking side to side. I'm looking at my y values. What's the highest my graph goes? 5. So my graph goes from -1 to 5. So my inequality notation for range is going to be -1 is less than or equal to y, because these are all my y values, is less than or equal to 5. this is left to right. This is bottom to top. Any questions about either of those? Okay. So then we are going to turn them both into interval notations. For interval notation, you're going to take the exact same numbers and you're just going to put a comma in between them instead of an X or a Y. I'm going to put -5, comma, 1. And then I have to choose whether I'm going to use parentheses or brackets. If it was a less than or equal to symbol, which is what we're going to use with numbers, it's going to be a bracket. And so that one's also going to be a bracket. Okay, for our range, we're going to go from bottom to top. So we went from -1 to 5. So we list those two numbers, -1 to 5. And then once again, since we use the or equal to symbols, since those are numbers that are included, we make it all the way to -1 and all the way to +5. We're going to use those brackets. Okay, any questions right now? Okay, so let's go look at some of the ones that have arrows on them then. Because if there's no arrows, it's just going to be numbers. It's going to be all less than or equal to symbols. It's going to be all brackets. Anytime we have arrows, that's when infinity gets involved. So, this one... There you go. It's fine, just... This next one, we are, for our domain, going to go from left to right. So the furthest left we go is right there. The furthest left we go is at 1. So my furthest left x value is 1. That is less than or equal to all of my x values. What is the furthest to the right my x values go? And what'd you say? You said arrows. What'd you say? You said yes. Oh, and then you said yes for infinity. Okay. Okay. So, the furthest right thing on our graph are these arrows. Because the furthest right thing is an arrow, that means we go to infinity on the right side. So we are going to use a less than symbol because we can never quite be equal to infinity. So that'll be less than positive infinity. Okay, let's go look at our range. If we look at our graph, what is the lowest thing on our graph? An arrow, yeah, okay, which represents infinity. What's the highest thing on our graph? Also an arrow. Okay, this arrow is pointing down. Yes, it's pointing to the right. That's when we're dealing with domain. But when we're dealing with range, we're dealing with up and down. So this arrow is pointing down. This arrow is pointing up. So that means we're going from negative infinity to positive infinity. So negative infinity is less than all of our y values is less than positive infinity. Hey, any questions about the inequality notations and finding the initial values? Okay, so let's throw these into interval notation. So we always are just going to take these two numbers, so 1 to positive infinity, put a comma between them. And then to keep it simple for you guys, anytime you have a number today, the numbers are going to get a bracket. Anytime you have an infinity, you're going to put a parentheses on it. So this one has one bracket and one parentheses. Okay. Thank you. For our range for interval notation, my two numbers are actually both infinity, so it's just going to be negative infinity to positive infinity. And then anytime we've got infinities, they're getting parentheses. All right, very last one. What is the furthest to the left thing on this graph? So follow the graph all the way to the left. What's at the end there? An arrow. What's the furthest to the right thing? An arrow. Okay. When we are going from left to right, we always go from negative to positive. It's tempting to think because that's going up, it's positive. We don't care whether it's going up or down right now. We care that it's going towards the left. Okay? So our domain is negative infinity is less than x is less than positive infinity. Our domain is always going to be left to right. And then for range, what's the lowest thing on our graph? An arrow. What's the highest thing on our graph? An arrow. So it's going to be negative infinity is less than y is less than positive infinity. Okay, for our interval notation on both, they're going to look the exact same because it's just going to be negative infinity to positive infinity in parentheses. Negative infinity to positive infinity for domain. Negative infinity to positive infinity for range. Okay. I'm zooming out because I want to show you guys some patterns, and then we'll go back and talk about this one last is it a function thing. So we're not done. Don't put it away. Hold your horses. Today's not the quickest notes. That's why we didn't do them yesterday. Is because I knew we couldn't fit them in on a skinny day. Alright, so things to notice, patterns to notice. Anytime we have a number, with a number, we are going to have brackets and less than or equal to symbols. So number gets a less than or equal to symbol, gets a bracket. Less than or equal to symbol, bracket. Less than or equal to symbol, bracket. Anytime we have an infinity, it's going to get a less than and a parentheses. Okay? So less than symbols correspond to parentheses. Less than or equal to symbols correspond to brackets. That's the first thing I want to point out. Next thing I want to point out, every single domain has an x. X, x, x. Every single range has a y. Y, y, y. Domains are your x's, so they're always going to have x's. Range is your y, so they're always going to have y's. Then the last thing I want to point out, you are always going from left to right and bottom to top. Left is always going to be a smaller number than the right number. So negative 5 is smaller than 1. Negative 1 is smaller than 5. 1 is smaller than infinity. And here's the tricky part. People always want to write positive infinity to negative infinity. That's never going to be an option. It's always going to be negative infinity to positive infinity. If it's arrow to arrow, it's negative infinity to positive infinity. You can never have two negative infinities, you can never have two positive infinities, and you can never have positive infinity to negative infinity. That's never going to work either, okay? So you've got the setup here. Don't go crazy trying to do other things or go other directions. If you came in late, I would strongly recommend waiting until this video is uploaded and watching the video to understand where all of this is coming from. Okay, go ahead and flip this back over. We've got one more thing to talk about right here, which is the is it a function. So this entire unit is about functions. Almost everything we're going to see is a function. Today and tomorrow we'll see some stuff that's just relations, and we're going to identify whether it's a function or a relation. So a function is a relationship in which each x value has only one y value. For our graphs, we are going to use what is called the vertical line test to check this. What the vertical line test is that if a vertical line crosses the graph more than once, it is not a function. A vertical line, when we learned last semester Hoy-Bucks, vertical lines are x equals. So if I put x equals a number on my graph somewhere, and I'm going to get more than one corresponding y value, then that is not a function. So flipping back over to look at our examples, you want to think about just a vertical line going across this graph. If a vertical line went across this graph, there are lots of places where it would cross more than once. It would cross twice here. It would cross twice here. Okay? So this does not pass the vertical line test. This is not a function. Because if I were to tell you x equals -2, I don't know if y equals 5 or y equals -1. So that's not a function. That's like if I were to push a button on a vending machine, and I don't know what I'm going to get out. So the x input doesn't give me just one singular y input. That vending machine isn't functioning properly. Okay, this next one, same thing. If I were to draw a vertical line here, it's going to cross here and here. So it does not pass the vertical line test, and it is not a function. Okay, and then the very last one, I can draw a vertical line anywhere. So I can draw a vertical line here. It's only going to cross once. I can draw a vertical line here. It only crosses once. I can draw a vertical line right here. It only crosses once. I can draw a vertical line anywhere on that graph. It's never going to cross more than once. So this one is a function. This one is a yes. All right. Any questions right now? Okay, I'm going to stop this video so I can go ahead and get it uploaded. And